All right, we are back with another video. Today we are talking about 1 and 2 step equations. We are learning how to solve 1 and 2 step equations by applying inverse operations. Learning it because it is a fundamental skill in algebra that helps us understand relationships between quantities and real-world problems involving unknown values. You'll know you've learned it when you can solve a 1-step or 2-step equation independently and explain the steps used to find the solution. By the end of this lesson, you'll be able to solve 1-step equations involving addition, subtraction, multiplication, or division, and solve 2-step equations that require a combination of operations to isolate the variable. And also be able to check solutions by substituting answers back into the original equations. So let's get to work. All right, number 1, this was the I do of class. And we start with m plus 12 equals 10. Now, there's a number of things we need to know. Number 1, when you get a problem like this, what is your goal? Your goal is to do what's called solving for a variable, meaning that you need to find out what that variable is equal to, meaning that you need to get the variable by itself. How will we do that? With inverse operations. Your inverse operations, so the inverse of addition is subtraction. The inverse of subtraction is addition. The inverse of multiplication is division. And the inverse of division is multiplication. Okay? So, when you look at an equation, like this one, for example, first thing I always do is I draw a line through the equal sign. And the reason I do that is because I call this the fence. Because if you're going to cross the fence, you have to follow special rules. So in order to get m by itself, we now have to force 12 to cross the fence. Now, if you're going to cross the fence, you have to do it via the inverse operation. So if this is plus 12, the inverse of plus of addition is subtraction. So I'm going to subtract 12. That's going to get rid of 12 on this side of the equation. Okay? Because that's going to make it equal to 0. And then you don't even write 0 because it's nothing. So you're there. But now the other key part to the fence is that whatever you do on one side of the fence, you have to do to the other side of the fence. So if I'm subtracting 12 from this side of the fence, I have to subtract 12 from this side. So I do 10 minus 12. We go to our trusty calculator. 10 minus 12 is negative 2. As soon as I have just the variable by itself on one side, so just m equals negative 2, I am done. Okay? Now, what I can do is I can go back and substitute it in if I want to check. If I'm not sure that negative 2 is the correct answer, then I can check. So I'm going to go back to my original problem, except I'm going to take out m, and I'm going to put in negative 2. So we do negative 2 plus 12 equals 10. And then I can go to my calculator, and I can put in parentheses exactly as I wrote it, negative 2 plus 12, and hit equals, and it will tell me that is 10. 10 equals 10. That's good. We're right. Okay? Whenever you substitute something in, always use parentheses, because there's so many things that could happen to something you're substituting in that you always want to use parentheses, even if it looks silly. Okay? When you look at the one side of, and the, when you look at the rule of what you do to one side of the fence, you have to do to the other, think of it like a scale, right? So if you have a scale, you have this over here, and you have a plate, and you have this over here, and you have another plate. The goal is to keep the scale balanced. So if I have 6 things on each side of the scale, if I take one off of here, my scale becomes unbalanced and tilts down. The goal is to keep the scale balanced. So if I take one off the right side, I have to take one off the left side. That's why when I took 12 off the left side here, I had to take 12 off the right side so I can keep the scale balanced. Okay? Remind me of just trying to improve. That is a terrible drawing still. You know what? No, I'm actually proud of that. That's legit. We take that. All right. Number 2, we do -2 equals g minus. Okay. So, even though it looks a little bit different as the g is on the right side of the equation this time, we're still going to follow the same steps. We're going to draw the fence. And our goal is still to get g by itself. We want to get the letter by itself. So when I look at the letter, I see that I have to move this -9. And I say, how do I move -9? Well, it has to get moved across the fence, so I have to use the inverse operation. The inverse of subtraction is addition. So I'm going to add 9. And what I do to one side of the equation, I have to do to the other. -2 plus 9 is +7 equals g. And that's it. So now we go to our you do together. I gave 45 seconds for this you do. 45 seconds. And it was y minus 17 equals -37. So go ahead and take this time, pause the video, pause ye old video, set a timer for 45 seconds, see if you could do this one. All right, we're back. So your answer should be y equals -20. How do we get that? Well, we drew our fence. We know that the goal is to get y by itself. So I need to get rid of -17 by forcing it to cross the fence. I'm making it walk the plank. I'm making it, yeah. So to do that, I have to use the inverse operation. The inverse of subtraction is addition. So I'm going to add 17 to both sides. Shabam. -17 plus 17 is 0, so that's just gone. It's eliminated. -37 plus 17 is -20, which is how we arrived at our answer. So that's doing it via addition and subtraction. So now let's talk about what we have to do via multiplication and division. We're back to I do. Here we are once again. A over 9 equals -4. And this is always the one that trips people up. In all my experience with equation solving, this right here, this situation, A over 9, A over something, is what always trips people up. Here's what you have to think about, because a lot of us think about fractions. And when you think about fractions, you think about a numerator and a denominator. What you're not thinking about is that a fraction is actually division. And how can you remember that? Look at the sign for division. It looks like you have a dot in the numerator, a dot in the denominator, and a fraction bar. The division symbol looks like a fraction. You could just even write it really small right here. A over 9. Look at that. It's similar. So you have to remember that fractions are division. So you have to do the inverse operation of division, which is multiplication. So we're going to multiply, forgot to draw the fence, we're going to multiply this side of the fence by 9. We're going to multiply by whatever's in the denominator. And then we're going to, since we did that to one side of the fence, we got to do it to the other. So we're going to multiply this side by 9. Now, another thing people seem to have trouble understanding is why does this work? Because if you multiply this by 9, you're going to get 9a over 9. Okay? And when you have 9a divided by 9, your 9s will just cancel out. Because 9 divided by 9 is 1. And 1 is something you don't need to write. So you end up with just a equals -4 times 9, which is -36. So that's your answer. And if you want to check it, again, you can go back into the original problem. You can take out the a, put it in parentheses, put in the -36 that we found, divided by 9 equals -4. Then we go into our calculator right here, and we do -36 divided by 9, and it tells us that that is, in fact, -4, which means that -4 equals -4, which is a true statement, so it's correct. All right, let's go to the redo. We have -7y equals -91. All right. So when you see a situation like this, if you see a coefficient with a variable, we know, especially from when we were doing the last lesson about combined like terms and distribution and all that, we should know that a coefficient with a variable means that that is being multiplied. Remember when we did distribution, if we had -7 times y plus 1, and we said if you multiply it, you just smush them together, that's the result, okay? But, so you know if you don't see a sign between a number and a letter, number and a variable, constant and a variable, if you don't see a sign between it, you assume it's multiplication. So we go back to our inverse operations. What is the opposite of multiplication? It is division. So I'm going to divide by my coefficient. And in a similar vein to how we did it in the last problem, we know -7y over -7 is, just y, because -7 and -7 divided make 1, so they cancel out. And we just go to our calculator, and we do -91 divided by -7. That's not 7. And you get +13. And that's your answer. So we do one more. One more with the you do. This one I gave 45 seconds. Problem was 5m equals -20. So if you want to take 45 seconds, go ahead, pause the video. All right, we're back. The answer you should have gotten is -4. Why? Because this 5 is being multiplied to m, so by our inverse operation, we divide both sides of the fence by 5. Because remember, what you do to one side of the fence, where we divide by 5, you have to do the other side of the fence. So we have to divide by 5. -20 divided by 5 is -4. That's a terrible circle. Do better, Deets. Do better. So those are one-step equations. Now, let's take it up a notch to two-step equations. Two-step equations are like one-step equations, except they have 2 steps. So to solve a two-step equation, step 1, you have to undo your addition and subtraction. Undo addition and subtraction. And then, to remove the constant, and then undo multiplication and division to remove coefficient. Okay? So in this I will be showing you how to do 6x plus 8 equals 50. All right. So first thing we're going to do, we're still going to draw our fence, because the fence is still important, right? So step one, undo your addition and subtraction to remove the constant. When you look at solving an equation, essentially you're going to take PEMDAS that we learned a few lessons ago, and you're going to go in reverse order. Okay? So I want to get rid of my constant. Which one? Remember, the goal is to get x by itself. So I'm going to ask myself, which one of these is the constant on the same side of the fence as x? The answer is 8. So I'm going to use my inverse operation. So this is plus 8. The inverse of addition is subtraction. I'm going to remember that what I do to one side of the fence, I got to do to the other side. So that leaves me with 6x equals 50 minus 8 is 42. Now I got to get rid of the coefficient. This is being multiplied together. 6x is 6 times x, so we have to do the opposite of multiplication, which is divide. That cancels out. You get x equals 42 divided by 6 is 7. 42 divided by 6, 7. So you're just doing what we did in the one-step equations, and you're just doing it twice at the same time. Okay, we did the first 3 examples, which were addition and subtraction. So we did addition and subtraction. Then the next 3 examples were multiplication and division, where we did multiplication and division. Now we're just combining. Okay? All right, next box. This is we do 11 equals c divided by negative 5 plus 8. Okay, so we're still going to follow our order. Step 1, you want to draw the fence. Okay, step 1, undo addition and subtraction, remove the constant. We're trying to get c by itself. Our constant, not attached to the variable in any way, shape, or form, is 8. So we're going to do that by using the inverse operation of addition, which is subtraction. And if you're getting tired of hearing me say things like inverse operation, I get that. But I got news for you. I'm about to say it again. So step 1 is done. We undid our addition and subtraction. Now we have to get rid of the coefficient by undoing multiplication and division. Remember, a fraction is dividing. Fraction means division. So the opposite of that is to multiply by your denominator. Multiply by negative 5. Multiply by negative 5. That'll cancel out. So c will be by itself. Negative 5 times 3 is negative 15. Finally, for 2-step equations, we just did you do together. I gave you 4 minutes. Okay. To do 31 minus 12n equals 211. So, if you're following along, go ahead and pause the video. Give yourself 4 minutes. And try to work this one out. All right, and we're back. So, step 1, we said earlier, undo addition, subtraction to remove the constant. Now, we're going to look at the left side, because that's where our variable is. We're trying to get n by itself, so what do we want to get rid of? If we're removing the constant, our constant here is 31. And I look at you and I say, uh-oh, 31 doesn't have a sign in front of it. How do I know if I should add or subtract? Well, if you don't see a sign in front of it, if I give you the number, let's say, we're talking about money, if I say $5, what do you assume about that $5? If I say I'm going to give you $5, do I say I'm going to give you positive $5? No. So if you don't see a sign, you assume this is positive, meaning that your inverse operation is to subtract. Remember what you do to one side of the fence, you got to do to the other. So we get rid of our constant here. 31 minus 31 is 0. That leaves us with negative 12n equals 211 minus 31. Check the calculator. 211 minus 31 is 180. Now we've got to remove our coefficient by undoing addition and division. Sorry, undoing multiplication and division. Apologies, it's been a long day. Even though this has a minus sign out in front of it, it is still being multiplied to the n, because this negative 12 is not a constant, it's a coefficient. Okay? That's a very big thing that you need to realize. Even though there is a negative sign here, that does not mean that you add it. This negative 12 is still being tied to n by multiplication. So you're still going to divide by negative 12. Divide by your coefficient. Negative 12 divided by negative 12 makes 1. So that cancels. That leaves us with n equals 180 divided by negative 12, which is negative 15. And that is our answer. All right, so there's two more situations I want to quickly cover. I'm not going to do the full 3 problem rotation for it, but I do want to just address these situations. 1, let's say you have a situation like 2/3 x equals 10. Okay? If you have 2/3 x equals 10, you need to get rid of a fractional coefficient. If you want to get rid of a fractional coefficient, there's a couple ways you can think about it. Either A, you could divide by 2/3. Okay? Whoops. Divide by 2/3. This works especially if you're using a calculator. The calculator will do all the heavy lifting for you. So let's talk about that. So this would just be, you divide by 2/3, that would still cancel out. If you x equals, and to find 10 divided by 2/3, you just put in 10 divided by 2, ABC, 3. And if you're using a fraction in a denominator, you have to make sure that for the fraction you're using the ABC button. Okay? And that gives you 15. And that's it. That's using your resources. Or, doing the same problem, you could instead, if you don't want to use a calculator or you don't have access to a calculator, you could instead do what's called multiply by the reciprocal. The reciprocal is what you get when you flip a fraction upside down. So, the reciprocal of 2/3, flip it upside down, it would be 3/2. What you do to this side of the fence, you have to do to the other side. So, these 3's cancel out by cross-canceling. These 2 cancel out by cross-canceling, so you have to x equals. And you have to remember that to multiply the fraction, if you have a whole number, you put the whole number over 1, and then you just multiply across. 10 times 3 is 30. 1 times 2 is 2. 30 divided by 2, 15. Either way it works. If you want to have the calculator do the heavy lifting, you can. You just got to know how to put it in. Now, the last situation that I need to talk about. It's the one time you're not going to follow this rule. And here's what makes it special. Okay, so one thing I talked about earlier when we first brought up this was I said that by solving equations, you're essentially doing PEMDAS in reverse. And remember, when we did PEMDAS, I talked about how fractions are grouping symbols. In the rare occasion, I mean, you might see it once on the state test, but in the rare occasion where you see the entire expression up top over a fraction, we're talking the difference between this. In this situation, right, you would do subtract the 4 first. You would follow our typical steps that we had established, right? But in this situation where the entire thing is over the same denominator, you have to get rid of the denominator first. You have to break typical convention and do your multiplication and division first. So here, we multiply the entire thing by 2. That cancels out your denominator. And what you do to one side of the fence, you have to do the other. So we multiply this by 2 as well. And that leaves you with x plus 4 equals 6. Then you can do your addition and subtraction. You're going to get rid of the 4 by subtracting 4 from each side. You get x equals 2. This is the difference. If the entire thing is over the same denominator, you do your multiplication first. If it is only the variable over a denominator, you follow the typical steps of doing the addition and subtraction first. Okay? This is a very, very rare niche case that does not come up very often. But it comes up often enough that I want to make sure that you've at least seen it before. All right. So that is 1 and 2 step equations. Thank you for taking charge of your education and seeking out assistance if you needed it. If you have any more questions, feel free to ask me at school, and I will see you in class.